Okay, so I am going to wrap up the stresses on an equilibrium system, which is always a fun thing to wrap up, with pressure effects. So we've talked about concentration, we've talked about temperature, we're going to talk about pressure, and then end with catalyst. So a pressure effect only affects gases. So if you have a gas anywhere in the equation, that's a solid, but over here is a gas, then it will have an effect. The other thing is it will only have an effect if you have an uneven amount of molecules on both sides. So here, let's count the number of molecules I have. I have one molecule, and one. So here I have 2 moles or 2 molecules, and here I have 1 mole. If I increase pressure, so it's not a stress we put in the equation, it is going to shift to the side with the least number of molecules. So if I put pressure on this system, the whole system, the side with the most number of moles is going to be stressed, so it's going to shift away from that side, so it's going to shift forward. And then the same thing is true, so whatever the arrow points to will increase, and then these guys both will decrease. So let's just do one more example. Maybe you can figure it out on your own. See if you add pressure to this system right here, the second one that I drew. See if you can figure out which way the system will shift if we increase pressure. And then pause it and then come back. Okay, so if I look at this system, I have 4 moles on this side, and on this side I have 2 moles. So if I increase pressure, again, it's going to shift away from the side with the most number of molecules, so it's going to shift reverse. So what's going to happen is my reactants are going to increase in concentration, and these 2 guys are going to decrease. So remember, whatever the arrow points to increases, away from decreases. Okay, and then I have another one here. So why don't you go ahead and do the same thing. What if you increase the pressure on this last system right here? So increase pressure on this last system right here. Okay, so if I increase pressure, the side with the most number of gas molecules, which of course is this side because there's 1 and this side has none, it's going to shift away from that. So the concentration of this will increase, this will decrease, and this will decrease. Now, if you do the opposite, so if you reduce the pressure, it's going to shift to the side with the most number of molecules. So it's just the opposite. Okay, last thing that I want to explain with this one is, say you have something like A gas plus B gas is in equilibrium with C gas plus D gas. That should say gas over there. Okay, because I have 2 moles on this side and I have 2 moles on this side, there will be no effect. So pressure will have no effect because you have the same number of moles of gas on both sides. Okay, the other thing that has no effect is going to be a catalyst. So a catalyst with respect to a stress, catalysts do have a big effect, but not with respect to stress. So catalysts are not stresses. So they don't cause shifts. But what they do is they equally speed up the forward and the reverse reaction. So if you take a system that's exothermic, little review here, so exo is high-low, exo, and you add a catalyst to it, remember the catalyst will lower the peak or the activation energy. And then I look at the forward reaction. The forward reaction is going to take that shortcut, right? So it's going to go faster. And then I take a look at the reverse reaction, and the reverse reaction is also going to take that shortcut and go faster. So they're both going to go faster if you add a catalyst, but a catalyst is not considered a stress. And we are done with LeChatelier's. And again, there is a Google Meet today at 2 p.m. if you can make it and you are confused.